I'm going to record the session. The first and foremost step on any data science project is to understand the business problem. Say there is a business problem, and the business problem is as follows. Significant proportion of customers are defaulting on the loan. This is the problem which a bank is facing. If this is a problem which a bank is facing, then how would you go about fixing this, right? First thing is, you need to come up with business objectives. Then you have to come up with business constraints. And this is your business problem. Whenever you write business objectives or business constraints, you have to bear in mind something called as data optimization. Okay. According to data optimization, majorly people use two terms. One is minimize, another is maximize. Okay. What do you mean by minimize and what do you mean by maximize, right? You will understand this. So here, if significant proportion of customers are taking the loan and if they are not paying back, that is called as people defaulting on the loan. And that's a problem which a bank is facing. Then what do you want to do? What do you want to achieve? You want to minimize the number of defaulters. Simple. So if you use the term minimize or maximize, it will become very simple for you to explain to the customers and also for your own team to understand on what is it that you're trying to solve. Business objectives are clear. Then business constraints. Here also you need to ensure that there is data optimization terms which are used to the extent possible. So once you minimize the number of defaulters, right? Or let me tell you this, let me ask you this. If you want to build a prediction model or a regression based model, which will classify on whether a person will default on the loan or not, then what algorithm will you use? What regression technique will you use? Yeah, guys? Vamshi, Vinod, Vivek. What regression technique do you use? Yeah, can you guys unmute and say, which regression technique would you use if you want to build a classification model which will classify on whether a person will default on the loan or not?
Logistic regression.
Sorry, Vinod?
Logistic regression.
Absolutely. Absolutely. It is logistic regression. Now, what does your logistic regression give you as end result? Would it tell you that a person will default or not default, or would it give you probability values?
It says yes or no, right?
No, it will give you probability values.
Yes,
if the probability value is greater than 50%, you say yes, a person will default. If
0 or 1, right?
Sorry?
0 or 1?
0 or 1, yeah. If the probability value is greater than 0.5, you will say it is going to belong to class 1. Class 1 means people will default.
Is it 0.85 or 0.5? Like probability value?
Probability value is 0.5 that you choose as a midpoint. If there is greater than 50% chance that someone is going to default on the loan, what would you do? You will reject the loan.
Yeah.
If there is less than 50% chance that someone will default on the loan, then you will approve the loan, right? That's a midpoint.
Okay, we take the value, right? 0.5, like it is depend on us, right?
It depends on you completely, absolutely. So let me write this 0.5. Okay, so
yeah,
okay, we'll get there. We'll get there because this is a point that you choose based on your own, whether you're risk taking kind of a person or risk averse kind of a person, right? So I think we are jumping gun, so let's refrain from this now. So let's discuss this, but this point please raise it when we discuss about logistic regression. I would love to answer this. It's a very valid thing. So now here, business constraints, right? When you're trying to minimize the defaulters, and if your model predicts that there is 80% probability that someone will default, or whether there might be 60% probability that someone will default, or 52% someone will default, then what do? You keep rejecting the loans. If you keep rejecting the loans in that way, what will happen to your bank profits? What will happen to your bank profits? Will your profits go up or
No.
come down?
No, it won't go.
I'm rejecting the loan. I'm rejecting the loans based on my predictions. How do banks make profit?
By giving loans.
If you keep rejecting loans, then banks cannot get any interest. If banks do not get any interest, then they will not make profits. So your management will come back and put a constraint on you. They put a constraint, saying that while you try to minimize the defaulters, at the same time try to maximize the profits. Always there will be these constraints which will be levied on you, right? It won't be a smooth sail. Okay, let me try out with another example. Say, significant proportion of customers are calling the call center and complaining that they did not do credit card transaction, yet they received SMS that certain amount got deducted. What's happening? I am using a specific credit card, assume. Suddenly I get a message saying that 1 lakh amount has been deducted. Okay, I can understand if I give my credit card to my wife, right? All of a sudden you keep getting such surprise messages. But what if you don't give it to your wife and it's with you, credit card, but still certain amount got deducted from your account? What do? You immediately call center saying that, hey, I didn't do the transaction. I think there is some fraud transaction, but I got a message. Would you do that? Yeah. If a large proportion of customers, or significant rather, I would not say large, significant percent of customers are calling the call center to complain that, hey, we have not done the credit card transaction, someone else has done it. Then, if you are the data scientist, then what will be your business objective? What do you want to do? Yeah, guys. Vamshi, Vivek, Vinod, what do you do? What is your objective going to be? Like minimize defaulters, what do you want to do? Are you all there? Are you able to hear me?
Yes, Bharani, very good.
So you say, let me minimize the fraud which is happening. That is what you would do, minimize the fraud. Now think about a common sense example on how do you want to minimize fraud. One common sense way of minimizing the fraud is, each time someone does a credit card transaction, You'll have your call center folks call that person and say, hey, did you do the transaction, customer? If the customer says yes, then you're going to approve it. Otherwise, you'll decline it. But if someone keeps calling me, for example, if I'm customer and if I'm using credit card, and for each transaction, if they keep calling me, what would I say? I would say that, boss, you're bothering me a lot. Please do not call me. That means it is causing inconvenience to me. So your banks or your customer would put a condition on you. That's called as business constraint. What would that condition be? While you try to minimize a fraud, maximize a convenience. Right? Maximize convenience. Now it would be an interesting problem to solve. Very challenging problem to solve. Agree? So, first thing is understand the business problem. Understand the business objectives. Understand the business constraints. Document it. Get it approved, reviewed, signed, whatever be. Then move to the next step. Am I making sense? Is that clear with respect to the step 1? Perfect. Vinod, are you there? I see only Vivek and Vamshi responding. Yep, perfect. Guys, if you have slightest of the doubts, like the question that you have raised on should probability value always be evaluated against 0.5, please raise such questions. Right? We are going to discuss all of those. All right. The next step would be, okay, again, objective of this session is to ensure that I explain you about the entire data science project management methodology, thereby also do a quick recap kind of a thing. And from 15th onwards, I'll be taking a regular class data science training for all of our folks. If you're really interested, please do attend that. It will be for full day, 9 to 6. I would love to see you all in person, but if you cannot make it, then online should be okay. 9 to 6. 9 to 6. All right. The moment your business problem is clear, you proceed with data collection. Weekend, Saturday and Sunday. Okay. But it will start on Sunday, then from the next week onwards, it will be on Saturday and Sunday. As part of data collection, you have primarily 2 primary data sources and secondary data sources, or primary data collection, secondary data collection, whatever you want to say. Say a bank wants me to build a model which will help me predict on whether a person will default on the loan or not. But the bank already must be having database of all the customers who have taken loan and their payment history, how many of them are paying on time, how many of them are not paying on time. All this information, say, supposedly is available in database. Okay, then what will you do? You'll simply go to this database which has the data which is already captured, right? Which has the data which is already available, and then start analyzing the data. So data captured or collected beforehand, data collected beforehand is called as secondary data source. Okay, it could be relational database management systems, or your CRM systems, or FRM systems, or hospital management systems, or whatever be it, supply chain management systems, whatever. Right? However, the data that you need to build this particular loan default prediction model, maybe certain important variables are not available. They're not available in the database. Your bank says that, hey, I do not have the data. Maybe it is important, but I don't have it. If you do not have, what do? You try to collect the data at that point of time. Okay, and what techniques do you employ? Surveys and experiments. Now, let us take a hypothetical example. Say we sent you an email to fill a survey. So there are 5 pages, 10 questions each. Would you be filling the survey? Would you fill a survey if I send you an email? Or if you receive an email asking to fill a survey, would you do that? No. What
No.
would you say? I have better things to do rather than filling this survey. That is what you would intuitively think. Then for you to fill this survey, what should I do? If I have to somehow ensure that you give the review, what should I do?
Like maybe to give us a gift or something.
Ah,
Or
I'll say that if you fill, I'll give you a 500 rupees Amazon coupon, or
vouchers.
something in it for you. That will be cost, right? That will be costly. It has a cost aspect associated with it. So it'll be costly. Second, would someone fill the survey, or say I'm sending an email to all 1 lakh customers, will everyone fill at the word go? Even if I give that offer? No. I need to send again and again repeated reminders, right? So it is time consuming. Third, okay, it is costly. Okay, it is time consuming. What is the third thing? Third thing is
Like we won't get any proper survey. Like the analysis won't be correct exactly.
Data might be misleading, or there might be data quality issues. Why? Because if you give me 10 pages and if I say, if you say that, hey, I'm going to give you Amazon coupon, you know what I'll do? I'll say A, B, C, D, then A, B. Randomly, I'm going to take some points. So you'll run into data quality issues. Okay. However, the good part is you'll get exact data for the variable that you want. Here, in secondary data sources, you do not have certain variables, right? And you conduct a survey or experiment. When you conduct that, you'll get the exact variable, right? Data for the exact variable. So that's a good part. Good part. Here, it is easily available, effortless. It costs you zero. There might be data quality issues here also. You'll do data cleansing. Okay, but the exact variable of interest you may or may not have. All right, while we are talking about data collection, what data should I actually bank on? For that, we need to discuss about data types. The first thing is continuous, then we have discrete. Within continuous, you have 2 things. One is called as interval, another thing is ratio. Then when it comes to discrete, you have categorical and count. Within categorical, you might have binary and multiple. Within multiple, you might have nominal and ordinal. Please do not worry too much about, hey, are you going to share this or not? Yep, sure, I'll do that. Let me post it up. That's the language, okay? And one more thing, even before I forget, let me also give my account just in case you guys want to connect with me. All right, these two have given whatever I need. So that has a detailed explanation, guys. So you might want to get access to that. Okay, now categorical. Anything that you cannot represent in decimal format, if it doesn't make sense, it's categorical. Then you have continuous data. Binary means will a person default on the loan or not? Will an employee resign or not? Will a customer churn or not? Will a person claim insurance or not? All these are examples of binary. Multiple. Will a person purchase a red color car or a green color or blue color? That's nominal data. Ordinal means something that you can place in a sequence. That is, 1 minute, guys. Guys, I'm going to go get into another room here. For some strange reason, my eyes are burning. I think now seems like okay. In that room, for some strange reason, my eyes were burning. Okay, anyways. So we have binary and multiple data. Within multiple categories, if you have data which can be sequenced in an order, that means will a customer be satisfied or dissatisfied or neutral? Then it will be ordinal data. Okay, guys. If it cannot have any natural sequence, then it is nominal data. I'm sensing you know about interval and ratio. Interval means anything which is subjective. For example, if I say, oh my God, it is 16 degrees, it's very cold. And if I make a person who stays in Antarctica, if you have that person come and sit here, then he might say 16 degrees, it's too hot. So the term 16 degrees Celsius is subjective. It depends on person and it can be interpreted differently. But when it comes to ratio data, it is objective, right? Meaning, say I paid 10 rupees for tea and you also paid 10 rupees for tea. Both have paid 10 rupees. It doesn't change no matter which country you go to. The denomination or the value of currency will remain the same. Such data is called as ratio data. Number of cars crossing a traffic signal is a count data. Number of employees resigning, number of insurance policy claims which might happen, all these are count data. Okay, hope I'm making sense. So ratio data is the best. When you want to do data collection, when you want to get access to the data, to the extent possible, you have to bank on ratio data. All the statistical analysis on the planet you can perform. The next best is interval. The next best is ordinal. And the least preferred is nominal. You know what? Nominal data also has a lot of privacy issues which come with it. Name of a person, phone number of a person, email ID of a person. Though from statistical analysis perspective, they are very unimportant. They are very important from data security and privacy perspective, or data privacy perspective. Having access to such data means an overkill. I mean, you'll have to secure it, you have to protect it and all that. This is called as basically PII, personally identifiable information. Anything that can identify me as me. And am I speaking like Swami Nityananda? I'm not sure. But when I say which will identify me as me, I mean, if you give a name Bharani Kumar Depuru, it identifies that it's me. If you have my phone number, then that's me. It is associated with a person like me. So that kind of data, there'll be a lot of privacy associated with that. So when you do data collection, always try to ensure that you get ratio data to the extent possible. Any doubts until here? Vamshi Krishna, can you also please respond? Okay. You might feel that enough of asking, did you understand or not, just continue, right? But there is a reason behind why we are doing this, right? Okay, anyways. Once you have access to data, majority of your time you spend on what? Data cleansing or data preparation. Exploratory data analysis, feature engineering, all would be part of this. Yep, exactly. So data cleansing and preparation. The first things first. If you have outliers, what do? Outlier analysis or treatment. Outlier treatment. As part of this, there is I'm a proud owner of this word that I coined, 3R. Okay, let me explain about that. Right, and the 3R technique is retain, rectify, remove. Say you have sales data. Okay, say you have sales data. In the first month, sales was $1 million. Second month, sales was 880,000 USD. Third month, sales was 970,000 USD. In the fourth month, sales was 1.1 million USD. And on the fifth month, sales was $10 million. Suddenly your box plot will highlight this as an outlier. What would you do with this outlier? You first check with your finance team or accounting team. Guys, all these months I see 1,800,000, so on and so forth, and only in 1 month, only for one specific month, I see sales worth $10 million. It's a very large number. Are you sure it is $10 million? If your person says that no, accidentally I've added a 0, then what would you do? You'll rectify it. You just remove 0. You rectify it. But that's rectify basically, right? You rectify it and then continue with your analysis. That's rectified. Okay. Then retain. So it's $10 million. Then you'll ask, hey, how come you achieved such a big number? Then your staff might say that, do you know what? Our marketing team has done an amazing marketing. And because of this marketing initiative, our sales exploded to $10 million. Then you'll ask the team, so are you certain that the marketing team will continue this innovative marketing strategy into the future? If they say yes, then what would you do? You will retain this because you are certain that such numbers will continue to appear. So you'll retain that in your analysis. But if you're, say, your team told sales team or someone that, you know what, our marketing team has done a disaster. They invested $11 million on marketing, but we got back only $10 million. Oh, so would you be repeating in the future? If the answer is no, we won't repeat because it was a disastrous marketing strategy, then what will you do? You will delete that. Okay, that's called as remove. Uh-oh. That is what we mean by outlier analysis. The next, sometimes when you see all the sales data, accidentally certain values miss out for two reasons. One is maybe you deleted an entry because it was an outlier which was irrelevant, or maybe someone has missed out filling that, and then you have from June onwards. This value which is missing here is called as missing value, and you treat this missing value using a technique called as imputation. Why otherwise? Say this is sales, we have age, we have gender, we have income, all of that, right? Age is 32, 33, 29, 28, 36, 41, whatever bit, and gender you have male, female, then you have male, and then say you have income also, right? And then even if one value is missing, by default, the techniques that you apply, your machine learning or whatever be it, is going to delete this entire row. That means just because one cell value is missing, you will lose that data which is available. Here we have data available, but you'll miss that just because one value is missing. Okay, just because one value is missing, you lose those. So to ensure that you do not lose, what do? Yeah, we'll do that, Vivek. We'll do that. My intention was to cover everything at a high level so that you do not feel that any of the concepts are missed out. If any are missed out, you can let me know, and then we'll continue with this. Don't worry, friends. I'm here to help you. Okay, I'm there. Don't worry. I know your issue that there was certain issues with certain trainers, right? That's the reason why I'm trying to extend this. Okay. All right. If needed, next week also we'll have another session. Don't worry from that perspective. Okay. So if I were to replace this missing value with some logical value, then how would you replace? You'll simply take average of all the other values and replace this with that. That is called as what imputation? Mean imputation. But if you feel that there are outliers in this data, then you choose median imputation. And if you have a value missing here, you cannot take a mean or a median for this categorical data. So you take mode, right? The value which is repeating maximum times, mode imputation. Of course, you have regression, hot deck imputation, so on and so forth. Right? These are two. Third, normalization or standardization. What do you mean by normalization? What do you mean by standardization? And when do you actually use that? To understand that, I think I have to open some data set. Let me open cars data set. Are you guys aware of this? On when do you use standardization, normalization? What do you mean by that? In fact, why do you even do that?
For data preparation.
Making the data into single scale.
Why do you do that? Say you're trying to predict mileage of a vehicle. How do you calculate mileage? Say you get some value 0.28 plus 1.2 multiplied with horsepower minus 1.8 multiplied with top speed, then plus 0.3 multiplied by weight, plus 0.9 multiplied by volume, whatever be, you have those, assume. Now, let me put 0.7, something which is. Now, which of these variables will have the least impact on mileage given this data? If this is the data which is available and this is the equation that you have, which of these will have, which of the variables, horsepower, top speed, weight and volume, which of these will have the least influence or impact on mileage? What do you think? Yeah, friends.
Weight.
Weight will have the least influence. Why? Weight has a number which is very small, right? Good. That's a good thing. So now what I will do is, instead of representing weight in kgs, assume this weight is in kgs, I'll change this to pound. 2.2 kgs is 1 point. Why is it not coming? Multiplied with. Oh, look at this. The moment I started multiplying the value of weight with 2.2, you're getting a big number, which is bigger than your horsepower in majority of the cases. Now, which variable will have the least impact on mileage? Weight, which is in pounds, or horsepower? Or volume or top speed, which will have least impact?
Still weight will have the least impact. Weight.
Still weight.
Like we have just done for the calculation for the reason, right?
Sorry?
We have done this for only for calculation reason, right? We are converted into pounds.
So what if customer has not given you this weight in kgs? Customer has directly given you weight in pounds. Then, do you think the units which are given has to impact your mileage?
No.
Is that right? No, it's wrong.
Yeah.
That means I need to make data unitless. I need to make data unitless. Just because it is in kgs, the same vehicle which is giving mileage of 53, just in case I start measuring this weight of the vehicle in pounds, it should not give me more mileage, right? Then my algorithm is itself wrong. To counter such things, we do standardization or normalization, which will make your data unitless and scale free. All right. How do you do that? Normalization simple. Z is equal to x minus mu by sigma. Then standardization. I mean, those two terms, normalization, standardization, can be interchangeably used, folks. Okay. How do you do that? New variable is equal to x minus minimum value of x divided by max minus min. Okay, x minus min by max minus min. When you normalize it, all the variables which are normalized will have mean equal to 0 and standard deviation is equal to 1. When you standardize the data, all the variables which you have standardized will have a minimum value 0 and max value 1. That means you are able to bring those variables to a common scale, and the moment you do normalization or standardization, your data becomes unitless. So this issue that I've just shown, like weight is getting measured in pounds, then the values increase, hence mileage will increase. All those issues are ruled out. And then you also have one more technique which is closely related to the concept of the standardization. Let me try out. Hot deck imputation, or sorry, dummy variable creation. The technique that is used is called as one-hot encoding. Do you all know what is a one-hot encoding, guys? Are you aware of one-hot encoding? One-hot encoding is a very simple technique. Say I have gender, right? How do I create dummy variables? I'll say male is 1, female is 0. That's it. Why male, why female 0? Are you saying that male should always have a 1, female should always have a 0? Are we being gender biased? No. Alphabetically, F comes first. After that, M comes. Whatever alphabetically comes first is given a number 0, right? Then 1. It's as simple as that, right? So here, this gender is called as a factor with 2 levels. Because any variable which can take limited set of values is called as a factor. Gender, male, female, transgender, and a few other things, but those are limited. But when it comes to age, can you limit the age? No. So age is not a factor. Any variable which can take limited set of values is called as a factor. And how many levels do we have? Male and a female, 2 levels. When you have a factor with 2 levels, how many dummy variables did we create? 1. Now say you have a make of a car. In that way, is this make of a car a factor? Is that a factor? Guys, any variable is a factor if it can take limited set of values. What values can a make of a car take? Either petrol or diesel or CNG or LPG or electric or a few more, right? But the number of values which make of car can take are limited. It's not infinity. They are limited. So whenever you have a factor, I mean, here the factor has how many levels? Petrol, diesel, CNG, petrol. So this is a factor with 4 levels. When you have a factor with 4 levels, how many dummy variables should you create? 3. When you have factor with n levels, then how many dummy variables would you create? N minus 1.
N minus 1.
Exactly. Right? So here
Yeah.
you'll have petrol, diesel, and CNG. Right? If it's a petrol vehicle, I'll put a 1, 0 here. If it's a diesel vehicle, I'll put a 1, and then you'll have 0 here. This is petrol, so I'll put a 1, 0, 0. For CNG, I'll say 0, 0, and 1. Then for LPG, if I put all zeros, it is assumed that it is none of these. It is neither petrol nor diesel nor CNG. So ultimately, it is LPG. 1, 0, 0. Okay, clear with dummy variable creation. Now, what is the range of this dummy variable? What is the range of the dummy variable going to be? What is the minimum value and what is the maximum value? Guys, what is the minimum value in this?
0.
What is the maximum value?
1.
If you subtract those two, what is the range? 1.
1.
Simple. So whenever you have dummy variables in your data set, is it better to use standardization or normalization?
Standardization.
Exactly. Clear?
Yeah.
Yes, please be proactive in responding, otherwise I'll get demotivated, right? So don't demotivate me, please. That's a request. All right. Then we have transformation, log transformation, exponential transformation, all of those, reciprocal, square root, and all that. When do you do transformation? When your data are non-linear. If you want to make the data linear, you will do transformation. If your data are non-normal, to make your data normal, you do transformation. If you're suffering from collinearity problem or
Scarcity.
skedasticity problem. Yep, good that you remember. Yep. These are the various reasons. If you have such issues, you do transformation and see whether issue gets fixed or not. Okay. Then discretization or binning. Why do you do discretization or binning? Say, I give you a continuous variable called age. Is age continuous or discrete? Is this age continuous or discrete, guys? Come on, friends.
Continuous.
Continuous, exactly. How can I make this discrete?
By rounding out of like particular.
How? Can I not come up with buckets saying that any person whose age is less than or equal to 30 years is considered to be young? Anyone whose age is greater than or equal to 30 and less than 45 is middle age, and maybe greater than 45, greater than or equal to 45 could be old. I mean, something on those lines, right? So if you have continuous data, if you do this, you make your data discrete data. That's discretization or binning. Once all these things are done, then you move to something called as exploratory data analysis. Then you do first moment business decision or measures of central tendency, mean, median, mode. You know about second moment business decision then. Which is variance, standard deviation, range. Then you go ahead with third moment, then you go ahead with fourth moment, then you do graphical representation. In which you do box plot, histogram, QQ plot to determine normality, then you do scatter plot. All these are univariate, okay? Univariate means what? Univariate means single variable graphs. Then you do bivariate, scatter plot. All right. This exploratory data analysis is also called as descriptive analytics. Descriptive statistics, descriptive analytics, however you want to call that. Then you have something called as feature engineering. Within feature engineering, you have two things: feature extraction and then feature selection. What do you mean by feature extraction? Okay, let me take an example here. Say you need to predict credit score of a person. High the credit score, more are the chances that a person can get a loan for a low interest rate and more amount. Say there are two people, A and B. Say there are two people, A and B. Person A has a debt. Person A has a debt of 1 lakh. Person B has a debt of 1 crore. Okay. If you are a bank and if you have to lend a loan, whom would you lend the loan to? That person which has who has a debt of 1 lakh, or that to that person who has a debt of 1 crore? Whom would you lend the loan to?
Person A.
1 lakh.
Who all responded? Vamshi and Karen. I think one person didn't respond. Can you respond? Who didn't respond?
Person A, so we know.
A. Okay. Answer is wrong because you haven't done feature engineering. You also need to consider income.
Okay, okay.
Say the first person's income is 1 lakh, second person's income is 100 crores. Then you say, let me divide debt by income. Whoever has debt over income, very low value, that person will have high credit score. Not just bank A or ICICI Bank, HDFC or SBI or any bank on the planet will have access to the same kind of data. Everyone will have information about the debt of everyone, income of everyone and all that. But that person who is going to do feature engineering and consider important variables would become important. So now what will you say? You'll say, okay, I'll not use only debt, I'll also use income. But I'll not use these two in the most raw format. I'll do feature engineering. Using the existing data, I'm going to come up with more interesting variables, derived variables, debt over income. A few banks go to this extent and they do a good job. But there is a thin line of difference between good and best. What do best banks do? Will they stop here? No. What would they do then? When it comes to income, a lot of people have low income. And only small number of people have very high income. What is this plot called as if it appears like this? What distribution does it follow? Guys, what distribution does this follow? When you have a curve like this, exponential. It's not linear. It's exponential. The moment you have exponential, I mean, you feel that that variable debt or income, both of these actually follow exponential distribution. Then what do? So let me take log of debt divided by log of income. This new variable will give you a lot of information, and this is, I think, the best variable that you can, given the raw data. So feature engineering is given the raw data, trying to apply your domain knowledge, and if you try to come up with more meaningful derived variables, that's called as feature engineering, feature extraction rather. Okay, but did we do manually here? Yeah, manually we calculated. Since we have manually calculated, we exactly know what the new feature is. It's log of debt by log of income, right? Since we have manually did this, you can exactly identify what that variable is. Neural network, on the other hand, does automatic feature extraction. You need not do all these things manually. Automatically your neural network will understand the new features, but you will not be able to give a name to that new variable. Like your principal components, you don't know what that new variable is, right? In that way, you cannot give a specific name to the new variable in neural network. Okay. So if you cannot give a proper name to that new variable, and if you use it in your prediction model, then you'll be at risk, especially when regulatory bodies come and audit you. Say you're a bank, auditing regulatory bodies will come to you on a monthly basis or quarterly. They do an audit. Hey, how many people have applied for loan? 1,000. How many loans did you approve? 800. How many did you decline? 200. Why did you reject those loans? Those 200 loans? Do you know what? I supplied my algorithm to neural network, and it has done some feature engineering on that. And then I got the output that the person will default. No, not done. They'll give you a non-conformance. Hence, in places where interpretation becomes important, there you cannot use neural network. You have to manually extract the features, and then you have to supply those new features to your linear regression or logistic regression, where interpretation is possible. Clear? Just because I know neural network doesn't mean you'll apply that.
If there's huge data, example like 10,000 or 25,000 data.
25,000 what columns?
Yeah, like example like people in case if you have like 20,000 people.
Rows, right? You're speaking about rows, observations.
Okay.
Yeah, you can have even 30 lakhs, 40 lakhs, 50 lakhs. That's the minimum count that you'll work on. For all of this, you'll do the same thing, right?
We do everything manually, right? For everything.
Yeah, manually in the sense you'll use R or Python and you'll write a code.
Okay.
Yep, you do that. That is where your strength lies. That is truly going to differentiate your model from the other models. Data scientist sitting in ICICI Bank and a data scientist sitting in HDFC Bank will have more or less access to the same data. And you both know the same algorithms which anyone else knows.
Yes.
Then how would an HDFC data scientist prove his superiority? By actually accruing some domain knowledge or sitting with subject matter experts and getting these kind of good variables from the existing data. And then using these in the models. Okay, then feature selection. If you have say 100 input variables, you cannot use all 100. You need to decide what are the top 20 most important inputs. How would you do that? There's something called as lasso regression, ridge regression. From the next batch onwards, we are adding these two, not as part of webinar. They have to be explained as part of training. Lasso regression, ridge regression. Then you have information gain from decision tree. Then you'll have variable importance plot from random forest. Then you can use hypothesis testing. All these are classic examples of feature selection. Let me save it somewhere. All right. So from step 1 until step 3, it should take roughly 60 to 80% of your project time. If it takes less, that means you have not done sufficient exploration. 60%. So say your project is for 2 months, right? Then it's 2 months means 60 days, right? In 60 days, 36 days to 36, yeah, 36. 36 days to 48 days. You have to spend only on these 3 steps. And then you move towards data mining, within which you have supervised learning, which is also called as predictive modeling or your typical machine learning, within which you have something called as regression analysis, within which you have linear regression. You apply this when your output variable is continuous. You are least bothered about your input variables. Only if output is continuous, you simply go with linear. Logistic when your output is discrete with 2 categories. I made it mandate for our folks to explain about multinomial regression when your output variable is discrete in greater than 2 categories also. And also there is something called as ordinal when you have ordinal data. Then if you have count data, you go with Poisson regression or negative binomial regression. If you have too many zeros, for example, if you are, I got the privilege of working for Tinder. Tinder is a dating application. Here it is a taboo subject, but there in Western world it's a quite acceptable phenomenon. Okay. So what people do basically is you have to fill an application form, right? Well, when you register on Tinder, if you're married, you have to say that your status is married. But majority of them, what do they select in that column? Not married, 0. And okay, even if you assume that is categorical, right? It will also ask you a question on number of children that you have. And what do you think majority of them will fill that column with? Zero. Zero children, right? Not just that. Not just that. Okay. If you guys are working with various companies, right? So if you ask a question on how many insurance claims did we do? How many times did you claim insurance, etc.? If you keep asking the people on the floor, what do you think majority of them will respond to you? They will say, no, I never claimed insurance. So you'll have zeros throughout. Then you run into excessive zeros problem. Then you need to learn about zero inflated Poisson or zero inflated negative binomials. This is what truly differentiates you from the rest. When you sit in an interview and when you talk, everyone will speak about linear, everyone will speak about logistic. Where will you differentiate? By saying that multinomial, ordinal, Poisson, negative, zero inflated models. Those are very important. And why are regression analysis so important in the world that we are living in? Those are so important because you can interpret the coefficient values, beta naught, beta 1, etc. You can interpret. You know what that means? In neural network or support vector machine, which are black box techniques, such an interpretation does not exist. Okay? Then you have k nearest neighbor, then you have naive Bayes, then you have ensemble techniques. Within that you have decision tree, random forest, gradient boosting, extreme gradient boosting, and a boost. All these are wagging and boosting techniques. So I'm sure decision tree and random forest and ensemble were explained as part of your training, but we are going to add these three also as part of the next curriculum, guys. Okay, then you have black box techniques, in which you have neural network and support vector machine. So as part of neural network, we want to get into the depth of artificial neural network, which is also called as multi-layered perceptron. Meaning, we want to explain all these concepts such as what is a perceptron algorithm, how do you calculate weights, manually calculating the weights, what do you mean by multi-layered perceptron, how do you calculate the weights, what do you mean by learning rate, what do you mean by decay parameter, what are the various error functions that we use, such as mean squared error, mean absolute deviation, so on and so forth. Then if you have continuous, categorical variable, then you also use something called as cross entropy, right? So let me put it here. So how do you calculate weights for both perceptron and multi-layered perceptron? Then various error functions. Error is also called as cost function or a loss function, right? Categorical cross entropy, binary cross entropy, manually looking at all these things. Then you have various learning rates. Then what do you mean by epoch? What do you mean by iterations? What are the various optimization techniques which exist? Gradient descent algorithm, batch gradient descent, stochastic gradient descent, mini batch stochastic gradient descent, ADA boost, ADA delta, ADA grad, RMS prop, Nestrov momentum. You learn bunch of these. So we want to ensure that our people know A to Z about all the arguments of any neural network. So that's something which was missing certainly from our curriculum, data science, which we added. Then from support vector machine also we added some more meat around it, not just learning the very basics, right? Canon, Naives, okay, fine, I think these should do. Right? And then for all these techniques that you're seeing, there's a simple thing that happens. Any machine learning technique on the planet, what does it learn? If you want to predict mileage, right? What do you see? Mileage is output, and you have horsepower, volume, top speed, and weight. Any machine learning on the planet is meant to establish the mathematical correlation or relationship between y and x. That's it. If horsepower is 49, volume is 89, top speed is 104, and weight is 28, what will be the mileage? So you're in some sense establishing the correlation between output variable and all of your input variables. You're understanding the patterns. In linear regression, how do you establish that correlation between your output variable and input variables? Mathematically, y is equal to beta naught plus beta 1 into x, x1 plus beta 2 into x2 plus beta 3 into x3, so on and so forth. Okay, that's it. It's all about taking your output and your inputs and looking at the correlation between your output and input. Any mathematical, any machine learning algorithm does exactly this, nothing else. Okay, then say you have this historical data which is given to you guys. I can write it here, but that's okay. I'm not sure. Let me see. Are you guys able to see the board here?
I guess it won't be visible.
It won't be visible, right? Okay. Forgot my scribbling pad, but then let me try out. Okay. So in this historical data which is given to you, you will have output variable and input variables. Okay, y and x. Guess let's do one thing. Let's take 5 minutes break only and then come back. I'll just figure out if there is a scribbling pad. It will make a lot of sense for me to scribble and then explain, yeah, as opposed to drawing in this way. Let's take 5 minutes break and then come back. I could get access to this. Okay. Perfect, perfect. Now it'll be wonderful. Let's see. You'll have historical data, right? You'll have output variable and input variable. Say you want to predict the income of a person given the age, gender, and educational qualification. After the training, what will they get? Whenever you get the data, you split the data into training and test. This is going to hold true for all machine learning algorithms, people. Training, usually you split the data into 80% training and 20% test. When I say 80% training, you take this data and split it randomly into training and test. Say you have 10,000 observations. If I randomly split this data, what will happen? Row number 2, row number 4, row number 7, row number 10. In that way, you'll have certain numbers. If you count these 1, 2, 3, 4 in that way, you'll have total 8,000 entries because 80% of this. Then now what should you do? You have to build a model. What do you mean by building a model? You establish the mathematical relationship between y and x. Y is equal to beta naught plus beta 1 x1 plus beta 2 x2 plus beta 3 x3. So what did your model just learn? Your model has learned these parameters or coefficient values. Then what do? You test this on the test data. Of course, when you split the data into training and test, whatever is not part of your training will be part of your test. Output and inputs. So you have 2, 4, 7 in that way. So here you'll have 1, 3, 5, 6, 8, 9. In that way you'll have 2,000 entries. 20% of this. Then what you do is you go here, you take all these inputs and you substitute these inputs in this equation. What would you get? You'll get a predicted value. However, if you look at this, you have the actual value. And when you subtract your predicted value from actual value, when you subtract these two, the resultant is called as error. Error for this first entry. Then take these inputs and substitute these inputs in this equation. And then substitute these values in this equation. The moment you substitute these values in this equation, you get another predicted value. Then you take the actual value which is here and subtract this actual value from the predicted value. What do you get when you subtract these two? You get error. How many errors do you get? 2000 errors. Take all those 2000 errors and take an average of all those, you'll get mean error or mean squared error, whatever you want to calculate, right? Mean squared error or root mean squared error, whatever. So you'll get this error for test data. Next, what you should do is take the same equation and test it also on the training data. You get the test error, take this same model that you built and test it on the training data also. When you test it on the training data, once again, take these inputs, substitute here, you get the predicted value, and take the actual value here and subtract those two, you get error. Then go to the second row, take all these inputs, substitute in this equation, you get predicted value. Take the actual value here and then subtract those two, you get the error. So you get 8000 errors. And when you take root mean squared error or whatever be it, you get training error. Now what you have to do is you have to compare this training error and test error. If both training and test error, if both training and test error are small and close to each other, it is called as right fit. If training error is low and test error is high, it is called as overfitting. Overfitting is also called as variance. And then if training error is high, then obviously your test error also will be high. If both are high, then it's called as underfit or bias. Is this clear, friends? Sorry, I'm not used to writing so much, right? My hand is aching. Anyways, yeah. Is this clear? Vivek, Vinod have responded. Vamshi? Okay. This logic holds true no matter which machine learning algorithm that you speak about. Simple. Okay, so split the data into training and testing. Build model using training. Test the model, test data to get testing error. And test the model on train data to get training error. Okay, then what do? If training error and testing error are small and close to each other, it is right. Done. And to fix underfitting issue, amount of data should be more. To fix overfitting issue, we need to adjust regularization parameters. So I instructed our entire team to the group of trainers to ensure that when you discuss about each and every algorithm, ensure that you explain about regularization parameters of each and every algorithm. Then you have unsupervised learning, in which you have clustering. In clustering, you have k-means, hierarchical. Different names of k-means is non-hierarchical anyways. Then hierarchical is also called as agglomerative or divisive clustering technique. Then you also have DB scan. Okay. There's also Clara, optics, k-meteoroids, and all that. That will be part of your webinars. Everything cannot be covered in significant detail, right? Then you will have dimension reduction. As part of that, you'll learn about PCA and SVD. Both are important, by the way. Then you'll have association rules, market basket analysis, which is also called as affinity analysis. Excuse me for the spelling. In which you'll have lift ratio, support, confidence. Then you should learn about recommender systems, and you should know the code. Also, then you will have network analytics. I think these should do, guys. These should do pretty much. Okay, you'll be very confident if you do all these things. Then, why is it ready for meeting? You have forecasting or time series. In forecasting or time series, you have two things: model-based approaches and data-driven approaches. In model-based approaches, you have linear model, quadratic, exponential. so on and so forth. And then you have within seasonality, you'll have additive and multiplicative, right? And then you have data-driven approaches wherein you learn about autoregressive, moving average, exponential smoothing, ARIMA, Holt's or double exponential smoothing, Winters or Winters technique. All these are the various techniques which are available, right? So if you know all these things, nothing like that. I mean, you would have covered the entire majority of your data science. You can go with confidence, attend the interviews. And of course, there'll be free sessions on. I asked Ganesh to create a different WhatsApp group. There'll be separate thing which is machine learning on cloud. You'll have a free session on this. You'll have a free session on IoT, right? To understand where the data is coming from, how is it placed on cloud, how do you build these things. And then you'll also have our DBMS training. MySQL, basically, we can use that. What else? For cloud, it'll be on AWS because that's most sought after. Am I forgetting anything? Yeah, I think they should. Yep, these are all free for you guys. Yeah. Now let me ask. Yeah, Vivek, why not? Why not? But you know what? The same thing is placed here. The link that I shared, same thing. In fact, in slightly more detail, right? It'll be in slightly more detail. What do you mean cross-sectional, time series, so on and so forth. But in slightly more detail, I think this would be better for you guys. Okay.